it. So that's it about me.
Thank you, Sean. Claire?
Yeah, hi, I'm Claire Kopenhofer. I'm at Michigan State University. So we're an R1 institution. Our HPC center has about 20 combined research facilitators and system administrators, and we service a couple of state universities sort of elsewhere in the state of Michigan. Like Sean, I am a former astrophysicist. It's literally in my background right now. And so my job, I do research software development. I do teaching both in workshops and in a course. So I've designed a course for teaching high performance computing with Python. And I work tickets and correspond with users on our help desk hours. So wearing many different hats, many different ways of interacting with users of all different levels.
Great. Thank you. Um, you?
Sure. Hello, everyone. My name is Yue Yu, and I'm a senior research computing facilitator at University of California, Merced. And my role involves helping faculty and students navigate our campus HPC resources, from training users to optimize workflows to co-leading campus initiatives and organizing regional computing events. A little bit about me. My journey started in academia, where I spent nearly 15 years transitioning from a computational chemist into a full-time staff role, supporting research computing. During my graduate studies, I was deeply involved in HPC, running simulations, troubleshooting workflows. So after my PhD, I shifted my focus towards research facilitation, where I could support researchers, helping them design their research project. So yeah, that's all about me. Thank you.
Great. Thank you. Mark?
Hey there, my name's Mark Allen. I'm the HPC systems architect at University of Oregon, and I've been here about 6 years. I support both systems and researchers, a little bit more heavy on the systems side, but I love my engagement with the researchers and the individual touch that we're able to give most of them. Before Oregon, I was supporting ERP systems as well as HPC systems for Fortune 500 company in the oil and gas industry, as well as a brief stint at a national lab.
Oh, great. Thank you. Colin?
Yeah, so I'm Colin Bone. I'm the HPC Outreach and Training Specialist at the University of Nebraska. My role, like many of those here, is to work with researchers to help them get their workflows going from a laptop all the way to scaling at either the local cluster that we have or to national resources like Access or the National Research Platform. I kind of got into HPC a little differently, where I started off as a student worker right before I started my undergrad at UNL, worked all 4 years, and then got hired on full time when they stole me from the local school district. My background is in education, but I'm a big tech nerd, and so that kind of just meshed very well. Uh, if you see me at Perk, I'll tell you the real full reason of how I got into working in HPC, because it's quite a weird way I got in.
Oh, maybe it'll come out during the panel.
Maybe.
Thank you so much, Colin. And Tom?
Hi, I'm Tom Cheatham, University of Utah. Been a professor here in the College of Pharmacy for 25 years, became director for our High Performance Computing Center about 10 years ago. We've got a fairly large research computing and data operation, about 25 FTEs present, 4 or 5 facilitators who interface between the researchers, and the technology, and a variety of modalities from HPC to virtual machines to many types of storage. And I've been using computers since I was in high school, and so I have a lot of experience with this stuff. And I'm also chair of CARC, the Campus Research Computing Consortium, and was involved with the Advanced Cyberinfrastructure Research and Educator Facilitator project that kind of evolved into CARC in some sense.
Great. Thank you so much, Tom, and everyone, welcome. So want to make sure everyone's aware that we have some predetermined questions that we're going to go through, but please feel free to add your any questions that you may have to the chat, and we promise that we will address all of them. So we'll start with when a new research computing resource becomes available to your researchers, What are your processes for understanding the resource and figuring out how to teach it to the researchers? So any of you can start.
I guess I'll start, Tom, from Utah again. Um, we often develop new resources for the researchers, like the virtualized environments, like a Science DMZ for high-speed data transfer crossing, bypassing the firewalls, or object storage, Ceph-based. And so the facilitators or user service people and the systems people all get together and try to figure out how to use it and work it, and then develop that into use cases. And then we span between the researchers and put test users on there, get them to play with it, see how they like it, see where their problems are. Um,
Great. Do you have any specific examples that you can share?
well, all those technologies we developed, and we've also, pushed people to national resources like the Open Science Grid and uh, Exceed, Access, earlier TerraGrid. We have champions on our staff. But most people want to stay local. They don't want to go to the other resources. They like what they know. And we try not to go to radically new technologies. Like we're not going down the quantum path anytime soon. Our clusters are very similar and it's very similar workflow for each of them. And we try to keep them consistent. And we have monitoring tools in place to tell you if your jobs are efficient or not, both on the GPU and on the CPU. And we check for people abusing the interactive nodes with the Arbiter script that will kind of warn you if you're kind of abusing the machine to some degree, and lots of metrics and monitoring.
Great. Thank you, Tom. Claire?
Sure. Yeah. So, I guess I don't have a specific resource in mind necessarily, of too many new things we brought on. Well, that's not true. We had demoed, somebody came in and demoed a script for logging your bash history. It wanted to spit it off into a product to see if we were interested in it. And sort of my first thought whenever I hear about a new technology like that being pitched, is I'm trying to think of use cases for our users, right? I'm thankful to work on a team with a variety of research facilitators who have backgrounds in a variety of fields. Um, like I'm not too good at the bioinformatics side myself, but I've kind of picked some of it up from just interacting with users. And so my first thought, right, I can figure out pretty easily how to launch something myself. But trying to make it streamlined so that it can be painless for the users. Some technologies I've run into, like Dask is a Python library. I've had trouble getting it to work in a traditional HPC environment. And so while it's in my class, I'm trying to figure out a replacement because it's just too cumbersome, I think, for users to find useful. So it's what's the use case? Who would be interested in this based on what I know of different fields workflows? And then how can I make it as streamlined as possible? Because if there's a high barrier to entry, users are less likely to adopt it. So those are what I have in mind.
Mhm. I have a follow-on question, and anyone can answer this in addition to the original question is it typically one-on-one, or do you create workshops and seminars letting people know what's available?
Any and all. The more ways we can reach out to people and get them in touch. I mean, we'll do one-on-one. We'll hold courses for a specific research group. We'll hold courses for the campus. And I want to add to my previous answer, I don't believe in the philosophy of build it and they will come. We have to have a use case where there's a defined need for that resource that will develop it. Otherwise, I don't want to waste a bunch of my guys' time doing it. So one really problem area now is this NIST 800-171 compliance that we need for NIH controlled access data. That's killing us. That's a real big problem. But we're going down the path.
One of the things that we do at Michigan State is we've added sort of a convention to our online documentation that we call lab notebooks. And so these are web pages that we explicitly say are not going to be kept updated, right? We're not going to maintain it, as technologies evolve. So they're a snapshot in time, but it gives us the flexibility to put sort of more niche use cases or advertise new technologies and sort of these pages that we don't have to commit to maintaining. So that flexibility allows us to advertise sort of new features that show up with a lower stakes for both us and for the user.
Okay, thank you. Anyone else?
Well, at UC Merced, we recently launched Open on Demand. And this is a platform that is very easy to use and give a user a very like a web-based interface. So it's provide user a more accessible to the HPC program basically. So we first, like as a facilitator, I first dive into the program myself, try to learn the tools and try to get more familiarized with the platform myself. And then we launch a pilot program. Basically, we select a bunch of researchers to use the program first and try to gather their feedbacks. And then we tailor some training materials based on those earlier feedbacks. And then after the full rollout, we develop the full training programs. And then we also provide some one-on-one meetings too. So after a month-long program, we basically start gathering more and more feedbacks and start tailor those training materials as the program continues, and then continue giving those trainings and one-on-one meetings to try to support a new launch, basically. Yeah.
That's great. I like the iterative process and then also um, starting small with a few
Hmm.
people and then implementing it more broadly.
Right.
Anyone else?
Yeah,
Just jump in.
sure. I'll use Globus as an example. Definitely not a new technology, but new for us in some ways, and new for me, especially when I first joined U of O. Um, and so the first thing I'll do is keep it simple. So I'm going to search out for a quick start guide. Anywhere I can see that title or the getting started section, um, and just pour through that documentation. Also, perhaps how-to videos. The shorter and more to the point, the better, as far as I'm concerned. But then I like to find out, if I'm going to explain this to the user base, what's the flow? What's going to be the user experience? Mainly, what windows are they going to see? What are they, in this case with Globus, what are they going to click through? What's going to be the sequence and order of operations for them to get from where they first open the app to actually moving some data, and what hurdles they need to jump through in terms of authentication and joining the various groups. And then, of course, it's just installing it and testing it as much as I can to find that 80% use case, and then perhaps going to the CLI for some of the more advanced workflows. In our case, we're running the POSIX connector, and so we've had to create some add-on documentation on if you want to get your data up to, say, Amazon S3 or Google Drive or Dropbox, here's how you can do it using another tool, rclone, and creating documentation with lots of screenshots, which is cumbersome but super helpful. Um, and then, there's going to be more opportunities for us to create documentation because we're going to be moving to using Globus connectors for Ceph and S3 and Dropbox as well. So um, we use just the docs for our outside facing docs, and so we'll create as clear documentation as we can and um, shoot that out to our user base through our monthly newsletter, and then partnership most with something that gets a little bit more complicated. We might partner with our library and hold workshops in the library so that we can meet people where they're at and have a more of a one-on-one facing engagement.
Makes a lot of sense. Thank you. Sean?
Yeah, I'd just like to add that especially if you work in a smaller institution and uh, oftentimes to me, the most valuable way to learn about any of these things is really to get to talk to the users and the user groups. And the more you communicate with them and the more they trust you, they will often show you, hey, here's what I want to do. Here's this workflow. And I think Thomas was talking about like these custom, developing, implementing innovative solutions and all that. But I totally agree. It's not if you build it, they will come. Rather, you have to build it for a purpose, right? And if you know your users and you know what those groups want, and you also know how to talk to them, right? It's not the same thing to use, Globus that's going to be for, maybe a social science department or whatnot versus CS, and so sometimes you have to learn how to talk a little bit about those languages, and then hearing from the users will kind of guide you on how to best express yourself and how to best convey that message.
Yeah, and it's evolution. As you start out as a facilitator coming from graduate school, you speak your one language. Mine was Comp Chem. And over time, you'll start learning these other languages of the other people by having these conversations, which are very valuable. And it's rewarding. It's a rewarding job. My facilitators are pretty happy. They get a lot of praise. Central IT gets criticized all the time. We get praised in research computing and data.
It's great.
Exactly. Yeah.
Yeah, here in New Jersey, we have a CC Star Regional Connectivity Award, and we have 7 institutions as part of it. And in implementing the Science DMZ, we're starting out small, piloting 2 science drivers at a time at an institution just to get things started. And then we're going to extend it more broadly to other science drivers. Colin?
Yeah, so for me, it's kind of just whittling down what the resource is and what users need to learn ahead of time for actually using it. And for especially new things, the easiest way is for me to try and learn and write down all of my mistakes, because there's a good chance that if I make a mistake, they will more than likely make that mistake as well. But it's also figuring out what is this best used for? What can I use to attract users to this platform? And for us, recently, we have a CC Star file system that we just deployed a year ago, where its big selling point is that it's accessible via Samba, so you can get it on your laptop or desktop on campus or with a VPN. But even a year later, it's still a thing we need to advertise better of. This is a cool thing where you don't have to go and download your results as a separate step to view them. It's something you can just go straight on and access. And for those researchers who are more self-driven and have already started exploring it, they've praised it for it's so easy to get results and access data. So it goes back to the you need to go fish for them rather than wait with a little fish net and hope they swim into it.
Yeah, makes sense. Um, so you've shared a lot of, everyone has shared a lot of great information so far. Um, I'd like for you to share about what's the most difficult research computing resource that you've had to learn, an experience that you've had um, in your environment, and how you were able to overcome it.
I think I have some examples of I've interfaced with some technologies that were clearly designed for running on the cloud. And I don't come from much of a cloud heavy background. The terminology is very foreign to me. And, you know, in trying to map that, I try to map it back to sort of like the HPC world, because I've been very steeped in that for a very long time, undergrad and grad school. And so, like, um, mapping terminology and concepts for new things is sort of the biggest burden. I find cloud has the biggest amount of like mapping I have to do for the terminology and concepts. But um, yeah, and those kinds of resources have been the biggest hurdle for me. And so then in turn, I figured they're going to be an even bigger hurdle for users. And so thankfully, like I haven't been involved in teaching cloud resources. We have a cloud fellowship, and people have gone through Amazon's dedicated trainings for that. But sort of the mental model, I think, is the most different between the HPC world and the cloud world. And so it's sort of the biggest bridge I've had to make.
Yeah, thank you.
I'd say for me, it was probably the National Research Platform, just because kind of similar to Claire, it's a whole different architecture and technology that its language is different, how it functions on the back end is different. A lot of my computational experience has been running local services or doing stuff on an HPC cluster or just right on my own laptop. And with National Research Platform using Kubernetes, even though I was already familiar with Docker, it's how do I twist the view of packaging things and getting it ready to run on a thing where it's not just so here's a file system, go run it, submit your script and you're done. It's similar but different. And I think that was the biggest challenge for me, but also not having a project to help me learn it because you can do concepts all day, but unless you have a reason to learn it or use it, the concepts don't stick and things don't click as easily. And so I've been kind of working towards that. And one of those was writing lesson material for the carpentries. Another part of it was with the grant I'm partially funded by of writing training material and teaching workshops. So kind of on the side.
Yes. Thank you. Yeah, if everyone, as you're addressing it, and Claire and Colin did already, is it's one thing, something is difficult to learn, but it's also something else could be difficult to teach, or is it, once you've learned that, is it easy to teach? So if you could address both the learning aspect and the teaching aspect, that would be great.
Yeah, humorously for me, it's learning Bash and Python because I'm an old school T shell C person, so I haven't learned those yet. But realistically, the orchestration stuff is providing us a challenge, as is understanding Kubernetes in the cloud. We had a grant to compare on-prem to cloud price total cost of operations. And it took my guys like 2 years to get HPC workflows up in the various cloud providers so they could do in a few hours at any other university in the country because we all are running very similar systems. And so it's the mindset is very different with the cloud. That's my 2 cents.
Thank you.
Oh, and teaching the cloud, we worked with the Internet 2 class teaching for my staff, actually. We're in one of the early cohorts of teaching for the cloud. And even the cloud teachers don't know how to teach the cloud very well yeah, at the providers. So it's just challenging. I mean, to set up a web page is easy. To get an HPC workflow working or a larger, more complex workflow is challenging.
Thank you. Anyone else?
I'll add I'll give a non-answer for the first one, and it's one of the things that I had to learn is how to overcome maybe my own biases and perceptions of things. Years ago, I used to be, users would come and they wanted to do Jupyter notebooks or, a Jupyter lab. And I always thought like, why would you want to do that? Just do it in Python and batch jobs and all that. And now that's our day to day, right? Like the bulk of our business is this, and I love it. And sometimes you have to look beyond, that concept, that, preconception of like, that's not, HPC, or that's not the way I would do it, and then actually, do the right thing, which is, help the user accomplish what they want to accomplish. As far as teaching, I think one of the hardest things, which again, it's our day to day is like the concept of a scheduler, if it's Slurm or whatever you may use. To so many users, that's just such a crazy concept that, you click the thing and it doesn't run instantly. And you really have to grasp at good analogies, examples, show them, why this is the way it is and all that to really convince them like, yes, this is the way that we need to do it, and it's going to serve you best and serve us best to follow this way. So those are the two I have to contribute.
Great. Thank you.
I think I want to add something based on Sean's answer too. I will give a relative like a non-answer to the first question. My answer will be very abstract. I don't find particularly really hard to learn a specific software or deal with a piece of hardware. I think it's really difficult for me to learn is when individual researchers use this shared system in a very unpredictable way. For example, recently we had a researcher who actually used the scheduler, the Slurm. She launched thousands of jobs, but those jobs using srun, but run it in the background, which actually caused our system to have a Slurm scheduler failure. And we spent hours and hours trying to figure out why Slurm has this such failure, which impact all users. And this kind of small cases or this kind of rare cases we don't normally see. And those kind of cases we have to learn on the way. And that in that case, we pretty much have to learn because all the individual researchers, they actually use their own programs in a very unpredictable way. So we learn new things every day. In terms of how to teach, so basically we collect all those use cases and we write it down into the documentation page so that we learn it. We train our own research facilitators using the documentation as well. And we also train our users based on those learning cases or based on those cases so that they will try to avoid these mistakes in the future. Yeah, so I think for me, it's all those different situations, all those different cases that we're going to see every day. That's a learning experience nonstop.
Mhm.
Yeah.
That's great. That's what keeps things exciting.
Hmm.
Um, Anyone else with that particular question?
Yeah, I'll follow on what Sean started mentioning Slurm. Um, that was there's a abstraction layer there, and just understanding the hierarchy and a picture is worth 1,000 words in terms of how the head node functions and how the users access the cluster through the login nodes and what to do on the login nodes and what not to do on the login nodes in terms of load. Um, and and of course, answering the question, why isn't my job running, or what's the status of my job? And um, Slurm documentation is great, but it can be just um, you can fall into many holes reading through it, and then how to educate myself and then present that to the users. And um, like someone just mentioned, having a project is great. Coming up with little test scenarios to run your job. Um, uh, and um, so I'll just say I'm still learning on Slurm and still learning how to teach Slurm in the most efficient way to our users so that they can get the most out of it and see what is my job doing and why isn't it running.
Great, thank you. And I know there was a question about sharing links to user documentation, and um, individuals have posted some links in the chat. So, and anyone else want to address those two questions?
I think I'll add, looking at our planned questions, maybe I can elaborate on this more later. But one of the things that I find difficult to teach is GPUs. Thankfully, there's a lot of software that's already built that'll use GPUs for users. But I teach this high performance computing with Python class. I'm teaching programming, and programming for GPUs is a difficult beast. And I spend the entire semester building up the concepts that people will need to understand what is happening with their job when they run on GPU hardware. So.
Thank you. Thanks. And so I think at this point, we're going to ask if there are any questions in the audience. And if not, we'll continue with this line of questioning. Please feel free to add your questions to the chat and we'll address them as they come in. Um, so, in the spirit of helping our audience learn from our mistakes so that they can make exciting new mistakes instead of the same old mistakes, what's one of the well, it says one of the most simple mistakes you made in learning and or teaching a research computing resource. What did you learn from that?
Well, I'd say don't do system security upgrades during a class time that's online. They're trying to use the cluster. We've done this multiple times and disrupted classes, both academic classes and our own classes. And so we strive not to do that. But this is a challenge because we're supporting more and more academic classes with the Jupyter notebooks or open on demand or other things. And that means do we have to be 24/7 to support them, or we have to do all our downtimes when they're not in class or where the kids aren't doing homework? So those are our biggest challenges. So we try to overcome that.
Yeah, that's a big one.
I can echo that too. Um, I made an enemy with a professor that um, that I regret taking the cluster down. I surveyed my researchers and thought I had accounted for all the feedback of when the best time to take the cluster down for maintenance. I just needed it for a day, maybe a day and a half, and it happened to fall within the first. It, Again, we're straddling that line between um, research is the 500-pound gorilla that we're supporting, but we have a lot of classes that we're now running on the cluster, and their timetable is different than research. Research seems to be 24/7, but with a little bit of wiggle room. But the classes, if it's during finals week or if it's the first week of class when they're actually trying to jump on the cluster and get the class moving, those are critical times. And I took the cluster down on the second day of class when the professor was counting on it, and he never forgot. So I had to dig myself out of that hole for years.
As someone who teaches classes, one of the things that I had to get over was wanting to safeguard my students and our users from every possible mistake they could make, right? Like I have this desire that I have all this expertise. I know the big pitfalls. I've learned lessons. I want to just impart that to my users, right? In the interest of research efficiency so that they can avoid these mistakes. But it sort of turns into me just dumping too much material on them and it's not useful. So, especially as an instructor, I had to learn to allow students to fumble and make mistakes. And hopefully, I can structure, like the ideal is structuring instances where they intentionally make mistakes, and then I can guide them through them. But there's always unintentional mistakes. Um, every year, the first day of class is let's help everybody set up their Python environment. Even if they tried to set it up ahead of class, there's always stuff that happens. So I'm embracing letting students make mistakes.
Yeah. In a way, there's a balance because you do
Yeah,
learn a lot from your mistakes. Yeah.
the lessons are more impactful,
Yeah.
so if the students work through it themselves.
Anyone else have comments about that?
Well, as a user myself before, I used to be a computational chemist, so I use HPC as a user before, and I ran a lot of large simulations. And those files can be large and easily fill up the space or the storage space that I have when I was a user. So the mistake that I made was running rm-r -rf or -f to delete the files without having any backups. So it is a command that is very easy to use, very quick, very efficient. But until you realize that you have already permanently deleted the files, especially in a shared system like HPC system, for example, recovery can be very limited. So whenever you use a shared system, always double check when you delete the files, always make sure you have backups because you never know the system may be down, the file can be corrupted. So you always be cautious about the file management or the storage management when using the HPC system. Yeah.
Great. Thank you. Anyone else have any comments or experience that you'd like to share?
I have one where we always try to enable research, help the user do the thing, right? But I think over years you do have to find where that line is. And, sometimes it'll be, something even along the lines of like, hey, I have this data, it's on this USB drive, I need it on the cluster. And, don't ever plug in a USB drive into your cluster, all right? Even though it's easy to do, don't do it. And it's not, and it's not necessarily because you don't trust your users or something, but you do have to draw the line somewhere where, they have to make accommodations. You have to find, a better solution than perhaps the easiest one is, right? So that I think is one mistake that I did was just, at first is like, how can I do, any way we can accomplish this, but you have to limit it a little bit.
Thank you.
Yeah, and kind of bridging off of those as well. I think it's a case of you can tell them 101 times, but sometimes it just doesn't click until something bad happens or a mistake happens. And for us, That's probably with our Lustre file system that we have Robinhood running on, purging files after 6 months. And until they lose the files the first time and they need it, it's one of those mistakes that it takes too long to learn it, but it's also very painful when they do. But to answer the original question, for me, not necessarily on the computational side, but I've accidentally replied all to our mailing list of 3,500 users in a ticket. Thankfully, it was regarding a workshop, so I could write that off as extra advertising. And we did actually get a few registrations as a result, so I will not complain. But always check what you write and check what you click, which applies everywhere.
That's a big fear. Um,
Yeah, we had a similar situation with um, file systems here at Michigan, where the Scratch file system on one of the clusters was uh, we had all of the agreements out there that Scratch is going to be wiped in these periods of time. Don't use Scratch for anything other than temp space. Scratch is impermanent, and nothing is as permanent as an impermanent solution. So Scratch didn't get wiped for, I think, a period of several years on this cluster. And when we finally went through and had to do some rebuilds, Scratch got wiped, and the next day there's half a dozen tickets in the queue. Hey, where's my data? I had very important critical research data. Well, it was living on Scratch and it's gone. So that spoke a lot to writing. When you write your policies, we have to follow them ourselves too. So if we put it out there that we're going to do it this way, we have to do that. We have to follow it up. And speaking to learning from your mistakes, we've got an Ansible environment that handles a lot of the client connection to research computing. We break off, we have our HPC groups, and then we have some like dedicated resources. And we always were going to get around to making Ansible work for us and making it into a much more formal project. And that got its big push by someone putting a wild card in the limit for hosts for I think it was like the Apache install playbook. So suddenly 300 servers started installing Apache at once, not the one server that the person was looking to push the package to. So once we realized we made that mistake and did a lot of client overwriting and created a lot of work for ourselves, that turned into the driver of, all right, boys, let's sit down and make this into a proper tool. Oh, and let's make sure that we adjust the limit variable.
Thank you. So we're going to switch gears and focus on what's one of the smartest things that you did when you were learning and or teaching a research computing resource, whether if you realized it at the time or not.
For me, at least, especially over the years, it's been just writing, where it starts off as personal notes in Obsidian or Notepad or whatever you're using or Notion, and just learning what works, what doesn't, and eventually translating that into public docs, such as the lab notebooks I was mentioned earlier. But with workshops, especially, one of the big questions that we have both in person and online is where resources are, what's the important information, how can I access something in the future? And so developing logistics pages or sheets that we can hand out have been one of the biggest benefits for us teaching of this is the information you need to know, this is our procedure, kind of condense it down. When I finish this, I'll post a link to one of the example pages if someone wants to steal it. But just writing things down helps so much for our own memory, but also to be able to just give a link, especially in a support ticketing system of have this one common question link.
Mhm. Yeah, that's a good point. We here in New Jersey, I mentioned I work with small institutions all the way to the R1s. And so um, more and more, some of the smaller institutions are supporting HPC environments and they want to know just where do they start? And so I have a whole document with links to communities as well as resources, as well as where to go for help and questions. So um, documentation is really helpful.
Yeah, maybe following up on the documentation, pretty much anything I'll ever do with it's, building some software, an environment or whatnot. I try to document it in the best way I can. Hopefully it ends up being, something that's really nice to look at and easy to understand. But sometimes it's just some notes. But even having that and having them available for, future Sean or future, somebody to look at and, make some sense out of is invaluable. And in that same vein, one of the smartest things I did from the very beginning is when working with researchers, they would give an example of their work. I'd ask them like, can you share a simple example or whatnot of what you're trying to do? And over the years, I've gathered most of those, if not all of them. And so I have a whole collection of examples from all kinds of disciplines and little sample data sets and some scripts and whatnot. And that stuff is so easily, fleshed out into the examples learn templates or, sending it to another researcher on how to do stuff. Obviously, you have to be very careful not to share, if there was some data or whatnot that can't be shared. But just keeping an index of all that different work, throughout the years is so great. And it helps me to go back and look at that stuff and say like, oh yeah, this is how you do this or that's how you do that. And that's, I think, a good thing to do if you work with a lot of different departments, a lot of different researchers.
Mhm. Claire, did you have something you want to share?
Yeah, so actually this is what I was talking about with finding GPUs difficult to teach. Um, Again, right, I've had the privilege of being able to teach a semester-long course twice now. I've even written a PERC paper about it, so if you're going to PERC, you'll get to hear me talk about it. But I'm quite proud of how I managed to structure everything. Um, and our director asked me, he was like, "Can we break out the GPU part into a workshop?" And I said, like, really no, because I'm the entire semester is spent building concepts of like how your data maps to the hardware, right? The presumption of the course is, all right, you've been programming in Python and now you want to get more performance out. Well, now you have to learn more about how computers work, right? Like you are advanced enough and comfortable enough to make that step. So we're going to learn about how, data is stored in memory, how memory hierarchy works, how data moves around. I'm going to get you, even though I don't want anybody using Python MPI. There's many other versions of parallel Python that aren't, MPI calls. It gets people thinking about data movement explicitly, which is what you really need for GPUs. So, starting as that sort of like this is the end goal. What, if you want to write your own, Python kernels to run on the GPU, what do you need to know to get there? And building the course from that perspective. And so I'm very proud of how that worked out.
Thanks for sharing. And you mentioned PERC. So to all the panelists as well as the attendees, please feel free to provide information about PERC sessions that are related to this topic in the chat. Hey, anyone else want to share something that the smartest thing that they have done when learning or teaching a concept? Well, um, we'd like to open it up to the attendees to ask questions or just share your experience as well. Well, I'll continue with the questions and please
Yeah,
feel
and
free
I
to
think
jump
for
in.
one of the best things we did was we keep extending our training. So a number of years ago, started to do Python and R, and now we're doing workflows and data management and how to use GPUs and and what a GPU does. And it keeps expanding.
Yeah. Just as the technology is expanding, new resources are becoming available. Um,
Two things come to mind. One has already been said, and that's just notes. I go back and forth between Obsidian and the notebook sitting on my desk next to my keyboard. Um, Sometimes when that gets filled up with some good gold, I'll transfer that to Obsidian so that it's in electronic form as well. And then ultimately that's going to bubble up into a wiki article in our documentation. Sometimes that process doesn't happen as fast as I would like it to, but that's kind of the flow. And I do find that I have to write everything down or else I will forget because there's too much. And it seriously seems like it's all new to me each and every day. Um, so on the notes, that's my feedback there. One of the smartest things that we do, and it's again, it wasn't my idea, but it's super helpful, and that's our weekly office hours. It's not only a time for the team to gather and a bit of a team building session, but then when you get our researchers and our grad students and anyone coming in to ask a question, they get someone who's a software engineer and building our software. They get a systems person. They get our research facilitator. They got all these resources in the same room, and we just drop everything and want to take care of that question. And then, of course, that leads to ideas and how better can we help them. So just a big plug for weekly office hours is my main point.
it's great. Yeah, and someone in the chat, Jeremy, has included that just leveraging those you know in the community and asking them questions and having them help you through problems is really key too.
Yeah, we're fortunate to have a large team here at Michigan State, and we have a weekly sort of all hands meeting between all of us, and we're free to bring up issues. And so often people will bring up tickets that they're having, struggles with and can't figure out on their own, to pull on, the knowledge of other people just in the room. Um, I also kind of wanted to say with documentation, one thing that we end up sort of doing at MSU, for instance, like Mark mentioned Globus, right? Like when we want to teach our users about a tool like Globus, we you can't possibly rewrite all of Globus's documentation, but rather than saying like, here, just go read their website, we'll often write up something that's particular to MSU. So like almost like an MSU specific quick start guide, to sort of help our users understand these other tools in the context of our system. And I think that helps bridge the gap a lot.
Yeah, for sure. Um, there was a question in the chat, Austin G. Sweeney, that asks, how do you balance not doing build it and they will show up versus new technology like Podman and Open on Demand, where your users tend to come from the iPad's swipe poke land? Uh,
Well,
Anyone?
I can only speak for about experience with Open On Demand, but I truly see no negatives that can come from enabling technologies like Open On Demand on our infrastructure. You want your infrastructure, I want my infrastructure to be as widely used and by as many different types of users as possible. And originally, years ago, it was some, we all complained like, oh yeah, students, they only want to poke and swipe and do that type of stuff. But that's where they're at, and we can fight it all day long, but if we want, we want to enable science, we want to enable research, we want to enable classroom learning, it is definitely important to meet the user where they're at, right? And Open On Demand allows you to do that. It also does not inhibit any of your traditional users, that just want to use a terminal and VI or an SSH into the servers. They can do that too. So it really is an enhancement on top of your existing infrastructure. And thus, if that helps us, get to the new generation of researchers, helps us get to more students and to fill, the nooks and crannies where our coverage was lacking before. I think it's a win all around.
Yeah, to build on what Sean said, like, on demand also can serve as a bridge. So once users, if a user does not come from a very computationally heavy field, or the command line is daunting and intimidating, right? Open on demand provides a way to sort of get used to concepts on the system, right? It does schedule jobs. You have to request resources, CPUs, memory, and then perhaps as users become more comfortable, right? They might click on that terminal drop down and open up a terminal and start doing things from the command line. So we found it a really great way just to expand outside of traditional fields, right? Like very few physics graduate students are going to need their handheld to get onto the system, but your sociologist looking to use Stata on demand is the perfect solution to hand them. And then we can just continue to build it out with new apps. There's, Globus integration with the latest on demand. So it really enables all of these tools that even your traditional users end up picking up and using. It's really great.
Yeah, I can also say something about my own experience since we recently launched Open On Demand on our campus at UC Merced. Initially, yes, we did receive a lot of not really fairly negative, but like a very neutral feedback based on how we use Open On Demand. This is a new product. I don't want to try it. This is something that, yes, we always going to receive when we launch something new. The way that I approach to this problem is that a lot of user, especially students, they're more they accept the visual thing rather than reading the text. So we create a short video, like a tutorial, maybe like a 2 or 3 minute video, just give them a brief overview of this product, just attract their eyes first. And then we also create a platform. We use Slack to actually try to engage all the student users so that they can communicate within their own community to share their own thoughts, share their own suggestions, so that students can talk within their peers to share this particular product, for example. And we use this combined method, short video tutorial, as well as the Slack platform to allow them to communicate between themselves so that we successfully launch Open on Demand. And then we slowly gather feedback from researchers, PIs, and then we start training more and more users based on the feedback we gather. And then this is a way that we start approaching when we launch something new or launch something based on new technology, for example. Yeah, so we found this is an easier way for students to absorb this new knowledge. Yeah.
That's great.
Yeah, we've seen open on demand usage increasing massively and people love it.
Yeah. How do you decide how deep to go when teaching a complex tool or system, especially when there's diverse audience of beginners and then experienced users? Basically, how do you strike the balance between enough detail and information overload when you're teaching something?
I think it really depends on what the full objective is, but I'd say if you can cover it in 1 to 3 hours where people can easily schedule it in a time, they won't lose interest or get tired at the end of the day, and give them enough to where if they are really interested and can see the benefit of it, they can go explore it on their own. The goal should be to make it familiar and less scary, but not necessarily experts or masters yet. And so just gain them either familiar with the concepts or gain some hands-on activity to kind of see where it's at to where they can make those decisions later is probably how deep I try to aim. There are some times where it's dig a little deeper if I'm talking about something very niche, but as soon as you start going into the technical weeds, you start losing interest or you start causing confusion. And so it's finding that nice balance on the topic too, and deciding what's
Yeah,
important versus good to know, but can be later.
thank you.
Yeah, I will follow up a little bit too. I think I will start by identifying the core goal of the session, and I would let the audience know what everyone will be able to do by the end of the presentation or by the end of the training session, for example, to get them excited first. so that motivate them to learn through the session. And moreover, I also read the rooms. For example, I watch the sign for them when some students show the confusion phase or disengagement. I started change my style a little bit, try to recollaborate or try to change the style that I teach to engage the student, to encourage the student to learn in a more excited way. And teaching isn't just about the content. It's more about the how to make the learner to learn at all level and try to make themselves to more motivated to learn based on whatever the content that you want to convey to them. So that's why I think read the rooms and then set a goal at the beginning is really, really important.
Oh, that's great. A strategy I found really helpful is if it's possible to have some activities where the experienced users are with those who are not and more novice and helping them get through the process. So that teaching aspect is rewarding.
I kind of want to answer the question in a different context of like answering help desk tickets, right? So that's part of my job as a facilitator. And it can be difficult to judge a person's level of knowledge, like from a very brief ticket interaction, especially because some users are not used to that environment and they don't provide a lot of information up front. So I tend to err on a little bit over explaining. For instance, if I say, "Oh, if you're having problems with a Slurm job, can you upload your output script?" And I will usually say, like, it usually has the format job ID dot out, and it's in whatever directory you submitted the job from. Just, giving that extra information so that I'm not assuming that the user knows everything of what they're doing. And I think that helps come off sort of more personable to them. But then for that balance part, right, like I rely heavily on our internal documentation. Well, MSU's documentation is public, but for our system. And I will often do a like, if you want more information, see this link, right? Or, here's the full website, but this particular section or these particular bullet points seem like they'd be most relevant to you. So sort of signposting through these longer documents, I think is a good way to balance and text that trouble.
There's a question in the chat focused on, and I know that Tom, you brought up the cloud, on how places are teaching cloud-related topics. There are different methods and styles of teaching, from documentation to articles to videos and workshops, hands-on, without hands-on, getting vendors involved, but what ends up really working based on your experience?
Well, it's in my staff have learned how to do it, but we don't have much demand for the cloud. And the groups that use it, because they share their software with collaborators and they don't want them to use their local compute, they want them to pay for cloud. They figured it out on their own, usually through the help of the vendors. But vendors' classes can vary from uh, commercial marketing to detail technical. You got to get the right person to teach it.
Yeah, that's
We
true.
have we have a cloud fellowship here at MSU, and I'm not involved with it, but I can try to relate the details as I remember them. And we sort of recently sort of flipped how we teach it. It used to be our staff teaching cloud, technologies to everybody. Um, and sort of one of the problems we had was retention of students. It'd be like this semester-long fellowship. They were supposed to come with a project that they want to put on the cloud, and just people would sort of stop showing up. So what we did this last year that was very successful, we partnered with AWS to offer their courses, and I think they're like webinar sort of setup. And that was free to anyone who was able to come. Like you didn't have to apply. I mean, like the fellowship is free, but you get a stipend, right? So the classes were the lowest barrier to entry. Anybody to take them. You could learn cloud. You could figure out if it fits your use case or not. And then you could apply to the fellowship. And we got much more committed students after that sort of process of like, they were able to find out, oh, this doesn't work for me. Never mind, it's not a good use of my time, before we committed dollars and they committed, lots of time and presentations and things like that. So that was the model that we've tried this year that we found pretty useful. But again, it depends on having that project to help students really learn it.
Yeah. Um, and Lauren, Michael mentioned the carpentries instructor training. Have any of you, would any of you like to share your experience with it?
So for us, we generally try and get most of our facilitators instructor certified, just so that way they have experience with a good pedagogical method of teaching materials and communicating with users from the get-go. We try and apply this to the community developed lessons, especially where we want those lessons to help get those new topics because they're great for helping new users to a topic learn things, but also to help us learn enough to help them and then explore both on both sides. With some changes they've made recently, it's been a little harder to get some instructors certified, but it's still something we're focused on doing, especially as we hire more. It is a great program overall, though, and if you have not looked at it much or implemented it, I strongly encourage you to take a look because they do more than just software carpentry, but they also do data and library carpentries, and it's a great way to start building a relationship with your university's library system.
Yeah.
I haven't done the instructor training personally, but some of our staff have, and we ran a workshop that was open actually generally to the public, teaching R, Python, Git, Bash, sort of basic tools. And for us, it was a really good way to network with people in sort of those non-traditional computational fields, and also rebuild connections with our own library system and some of the staff at MSU that had sort of decayed over the years. So really the advantage of running the carpentry workshop, people did take things away, hopefully, and the goal of the carpentries is to give them enough to start playing around on their own, because it's a very full sessions. But the secondary benefit that arguably maybe even was even greater was the networking that it brought about by having that kind of meeting on campus.
I also want to browse a little bit about their content. So the carpentry website, they're basically open to all. Even if you don't have a certificate, you still can use their material to self-learn using the self-learn path. And recently, we actually launched a symbol arc program to allow the Central Valley users to start using our HPC through OSG. And before launching that program, we know that a lot of Central Valley students, they have very limited resources. Most of them don't have any experience or any background about computational research computing, basically. So we shared a lot of carpentry website to them to allow them to self-learn a little bit. And then we collaborate with our libraries to also offer the carpentry license, start from Linux basic commands all the way to HPC content too. So it is a very useful resource to actually allow users to learn from the instructors or as well as themselves.
Thank you. What strategies have you found most effective for engaging researchers who are reluctant to adopt new tools or workflows? Have you used incentives, or are there tactics that you can share with the um, group here? And I know, Tom, you mentioned at the beginning that um, typically, many times researchers want to use what's on-prem. And so how do you basically encourage them to adopt new tools and new resources?
Well, it's challenging. There's still a lot of people on our campus that don't know there's free research computing and data support available. And we try to send this message out all the time. And there's other issues of security and compliance where you have to have protected data or restricted data in specialized environments. And people don't want to go through the hoop. They just want to do it on their own little laptop or workstation in their office. And it's not ever compliant. So we had to convince the human genomics researchers to move into our protected environment, which is good for HIPAA, protected health information. It's just an ongoing challenge, but our number of users is growing. I mean, we've more than doubled a number of PIs in the last 5 years, um, and it's still growing
Yeah.
linearly.
I think
Yeah.
one of the things that helps us attract those users that would be inclined to spin up their own little cluster under their desk is that we have a buy-in program. So we allow research groups to purchase hardware, we'll host it and, make it part of the environment. They can have access to the file system and everything, but they get priority access to executing, jobs on that hardware. And I think that's been a really successful way of bringing in those sort of more people who are more, have the knowledge and know-how and belief that they can go out and do it on their own and to bring them into the unified resource. That's been very helpful.
I
Yeah,
think if you have that good relationship with the people, you're working with, and they trust you and they trust your team and your expertise and opinion, it makes that a lot easier. Because if you're just going to somebody who you've never met and say like, yeah, we got all this great stuff, really, why should they believe you, right? But when you've worked with these people, you work with the groups, people are vouching for you, it just makes that go so much smoother because they know, oh well, they're probably serious, they know what they're doing. And then pretty soon they trust all, you're saying like, look at this thing, that's really good, and they're going to be very happy to use it because they know that they can trust, what you're giving them, right?
Great. When
Outreach outreach engagements are super important. It still may so yeah, I can fall prey to having the blinders on, and it just blows me away when folks don't actually know that we exist and the resources that are available for free, and the support that's available, and so certainly through word of mouth, through partnering with the libraries and introduction to HPC workshops, um, and then just general networking and our relationships with PIs in the different colleges, and hopefully the good words that come from them can all spread the word so that we can help more and more nooks and crannies in the university. Um, I'm sorry, I just had a thought and it just left me.
It's okay. Other people's answers are prompting a lot of thoughts in me. So another thing that we do is we always send somebody to our new faculty orientation, to sort of advertise to new faculty coming in that this resource exists. And I think that's also been really successful because, of course, new faculty are like, great, I don't have to spend startup funds on hardware, right? Like I can use this thing that's already there.
Thanks, Clay. That helped get my thought back. So we run both shared resources that are free, as well as condo environments. And so part of what we try to do is show back. Let me show back to the researcher, essentially um, the the free components that they're going to get, should they want to invest in a condo, to incorporate that resource into the greater cluster. We show back what you're going to get. We're going to give you X amount of free high-speed storage. We're going to essentially pay for the networking to connect you up to the storage and to the cluster, and so on. Um, we we pay for your security posture, and then try to let them know how that is important, not just for their data, but for the university and the university's reputation, um, as a whole. And so the showback is an important part of showing what they can get if they want to, not try to go off on their own and reinvent the wheel underneath their desk.
and kind of going into what we've been discussing, I think one of the bigger challenges is just to not only find the people that should be using our resources that don't know about it, but how do we make the cost of it low enough, not just financially, but also time and effort and learning to start using these resources. Because one of the biggest things that we have for the laptop to supercomputer transition, but also the supercomputer to National Research Platform OSG access or exceed, is is it worth the researchers' time and effort to go and learn these new resources to potentially accelerate their research? We may know it as facilitators that it will more than likely accelerate it, but until the researcher has their own concrete proof that it accelerates, it's still a gamble for them. And so that's been one of the other challenges we've been working on at Nebraska and within the Great Plains region for the National Research Platform.
Thank you. I have a question related to sustainability. As technology continues to evolve, how do you, when you're developing your training materials and workshops, how do you address sustainability? Um, you know, through modularization of your materials or uh, iterations of the training material. Any insights on that?
I'd say my team is constantly improving their training, and based on experience, they learn from one year what they need to improve for the next year and what level, how deep to go. But sustainability is like a four-letter word in research computing and data because I don't know any of us that are really sustainable.
It's true. We only have 2 more minutes, and in the next 2 minutes, I'd like to ask, several tools and technologies have come up throughout this session. What's one emerging or underutilized method or tool for teaching research computing that you think more people should know about? I know we talked about open on demand. Um, are there tools that you would recommend that people learn about and teach about?
I don't know if it's new to anyone on this call, but my class is based on using Jupyter notebooks because of the mixed text and coding, and it allows students to have a very active, hands-on learning experience. And I think in computing, that's absolutely critical.
Yeah.
Yeah, I'll second Jupyter Notebooks. I actually um uh, it's fascinating. I think it definitely lowers the entry to both Python as well as getting on the cluster itself. And it's super cool how it can actually run shell commands within the notebook context.
Yeah, I have to agree with that too. With within GPN, we use that to help teach NRP. Just we can spin it up on a Jupyter Hub instance we host with kubectl on it, which is the application to interact with the Kubernetes cluster like NRP. And the other big benefit, especially for students in a class, is at the end of the day, they can take that home and they have a reference of the text that was mentioned, they have reference of the commands that were explained and that they used at the same time. So it's just so beneficial that we have a tool that allows us to do this. I think the caveat to it is it's also very easy to just write a notebook that students can shift enter and just or just click run all on and run through it. And at that point it's a presentation, not a training, in my opinion. And I can see Claire is really heavily agreeing with me.
Hmm.
I've
Yeah.
done those tutorials, yeah. Um, I guess also I'll say a lot of our users have started using VS Code as the main way they connect to the cluster, with a terminal and a Jupyter notebook. And it has some weird pitfalls, but we've actually put a code server, like the open source underpinnings of VS Code app into on demand. And that's been a nice little workaround for people that have trouble connecting their personal VS Code.
Yeah,
Yeah, I saw the comment saying VS Code memory leaks. Yes, we experience the same issue. Our user, they use VS Code, and then, yeah, we do have a lot of memory issues on our cluster. Yeah.
for us, we actually had a different issue with VS Code where when they used the remote connection tool for it to talk to our cluster, it would leave zombie processes after it died. And because on the login node we limit user processes to I think 250 in total, it would get to the point where we would have users failing to log in. And when you have a class using VS Code, that's a lot of angry emails. But we managed to limit the processes themselves to 240, so that way there's always 10 free and wrote documentation for users on how to fix it if it ever happens.
Well, we're up on our time. I want to thank all the panelists and the attendees for your engagement. Thank you so much. I certainly learned a lot, and I believe the recordings will be made available through Henry Neiman. Have a great afternoon, and thank you again.
Yes, thank you all for a fantastic panel. And once more, you can see just by the amount of traffic in the Zoom chat, this has been really engaging and very valuable for our audience, our facilitators, which is exactly why we're here. This is exactly what we hope to get from the session. So thank you all very much. Quick program note, our final session of the day this afternoon is Research Networking Overview from Wallace Chase of the University of Otago and Aaron Marui from the Research and Education Advanced Network New Zealand. So they are both in New Zealand, which is 19 hours ahead, meaning 7 hours behind. So it's bright and early in the morning for our New Zealand colleagues, and they will be joining us at quarter after the hour. So about 26 and a half minutes from now. We look forward to seeing you all. We're going to leave the session live. We encourage you to stay logged in, and we'll be back real soon at quarter after the hour. Thank you all, and I'm going to stop the recording.